second question asks us to find out the data set penduduk analysis regresi minimal 5 variables. The same. Okay, description regression analysis on insurance data set. As I just read before, and I will continue about it. As an example about this, why we have this data set, the attribute of it has numeric data type and it is also policy holder. It becomes one of the important attributes since health risks and insurance costs, typically insurance, increase with age. Age-nya bisa ganti. That's why we have something to do with it, with regression analysis. Okay? And then reasons to choose these variables. The variables I have chosen are written in bold font. As we mentioned about it in the description section, the insurance data is profound suited for regression analysis due to its continuous dependent variable like charge and the existence of predictor variables such as age, sex, BMI, children, smoker, and region, as well as multiple linear regression and SVR are accurate method to implement to this data set. The main reason is because each offering different strengths in modeling relationship between these variables. This powerful modeling can be seen through careful pre-processing. Okay, these are what we all know. That's why we are capable to retrieve valuable insights. Okay, now, that's the important point in here. Multiple linear regression. What is it? It is a categorical variables faces with the categorical variables. Multiple linear regression expects data numeric values before fitting to the model. That's why in order to convert this, we need to go through some steps in here. So let's start pre-processing the data. So the information in order to differentiate between the categorical and numeric variable. After that, with scaling purpose of numerical features on one hot encoding categorical feature, I developed transformers. In this point, I created a column transformer by merging these transformers as it shows below. In here, you can see the coding that helped us to bring some variables into numeric form in order to fit it in our model. So, and then definitely we will use pipeline. Once we created the column transfer, setelah itu pipeline-nya sama preprocessor regressor kita pakai. Jadi biar menjelaskan atau make it correct to be used or fit with the model. Evaluation of multi. Now we will evaluasi multiple linear regression. These are significant difference of various in targeting variable. Nonetheless, the MAE and RMSE indicates that the prediction errors are relatively large, in which that the suggestion would be room for further improvement. Nah, ini suggestnya bisa lebih improvement and relatively large. Prediksinya ada errors tapi relatively large. The possibility is through more modeling techniques furthermore. Techniques. Jadi itu rekomendasinya lebih kalau kita pakai modeling techniques yang beda-beda. Jadi ini evaluasinya. Maksud saya yang kita memberikan di sini, Anda dapatkan perjawabannya di sini, kita menjelaskan yang ini. Okay? Jadi it is talking about MAE and RMSE, and the MAE as predicted on average deviate from actual insurance value, and the MSE, the prediction between scored and the actual predicted insurance is about a large number 335969115. This higher value indicates that there are some larger errors, as we just mentioned in the first paragraph in here. In here indicates that the prediction errors are relatively large, in which that the suggestion would be room for further improvement. Jadi itu di sini sudah kita membahaskan tentang ini. Okay, the RMSE is about $5,796, indicating the model's prediction error in the same units as the insurance charges. Okay, and the last one talks about the number in there that approximately 78% of the variance in the insurance charges explained by the model. This indicates as a good fit, though there are still room to improve. Semuanya harusnya masih improve, masih terlalu different good techniques for it. Okay, SVR model. As we have done the pre-processing of data numeric and categorical variable in previous model, now we are just expected to fit the transform X train with the preprocessor. And this is how we did it. Okay, and the result says that based on the given data, the SVR model performs less effectively than the linear regression model, specifically in accuracy and supplementary ability according to insurance charges. Okay, so it happens, different models, different data, and sometimes it is helpful, sometimes it brings the best result, but sometimes the data has some errors. That's why we do not have the related accuracy. As the SVR SME, an approximate huge number of SVR MSE measures the average square difference between predicted and actual values, and RMSE, providing a scale in the same units as the target variable. It signifies the extent of prediction errors. And then the SVR2, there are indicates that only about 13% of the variance in the insurance charges is explained by the SVR model. A low R2 suggests that the model's predictions do not closely fit. So it is indicating limited predictive power. SVR MAE 5,967 indicates on average the predictions differ from the actual insurance charges up to 5,967, as it shows in here. We have the result, there are errors, there are thousands of errors. That's why we are implementing these models. As the conclusion, which is very important, if we put this into words, analysis of insurance prediction charges using different regression models such as multiple linear regression and support vector regression and various kernels. That's why we can conclude several things based on these evaluation metrics. On the one hand, multiple linear regression provides a baseline performance with the various metrics such as MSE and MAE, but the MAPE indicates on average prediction as off by almost 13% from the actual values. It assumes a linear relationship between predictor and the target variables. SVR with sigmund kernel shows the lowest performance among all with highest SME and MAP. On the other hand, SVR with RBF kernel performs more better than both linear regression and SVR with linear kernel using MSE and MAP. It shows nonlinear approach implementing RBF kernel can capture more complex relationships in the data, and SVR with linear kernel performed similar to the MLR in the same terms mentioned above. Jadi, it surely suggests that the data significantly not benefit from the nonlinear transformer provided by the RBF kernel. Overall, kita bisa bilang SVR with RBF kernel combines as a preferred model for insurance charges prediction in this data set. It is capable to achieve lower MSE and MAP if we compare with the other models, since it indicates better and accurate prediction and have got the ability to capture non-linear relationship. Next video for the last question.